In this video, I'll round out our discussion of the pre-Socratic metaphysical philosophers, cosmologists, proto-scientists, with the discussion of ancient atomism, as well as Melissus and Philolis, very briefly at the end. Most of the time will be spent talking about atomism. Leucippus was the founding father of ancient atomism, but Democritus is better known. In fact, not much is known about Leucippus at all, other than Democritus was said to be his disciple, and joint views are often attributed to both of them together. These philosophers proposed a mechanistic theory. Motion was to be explained by direct contact of bodies, pushes and pulls and entanglements. This theory would become the major competitor in the history of Western philosophy to Platonism and Aristotelianism, which contrasted with atomism in being teleological, that is, being purpose-driven, in positing goals or ends as part of nature. When Platonism and Aristotelianism became the philosophical foundation of Christianity and later on medieval science, modern science and atheism and naturalism and materialism would latch on to ancient atomism as the main philosophical alternative. The basic atomistic conception of reality is that reality is composed of atoms in a void. So we see in number 6 here on page 53, Leucippus did not follow the same route as Parmenides and Xenophanes concerning things that are, but seemingly the opposite one. For while he made the universe one, immovable, ungenerated, and limited, and did not even permit the investigation of what is not, they, that is the Parmenides and Xenophanes, made the universe one, immovable, ungenerated, and limited, and did not even permit the investigation of what is not. He, Leucippus, posited the atoms as infinite and ever-moving elements with an infinite number of shapes on the grounds that they are no more like this than like that, and because he observed that coming to be and change are unceasing among the things that are. Further, he posited that what is no more than what is not, and both are equally causes of things that come to be. For supposing the substance of atoms to be compact and full, he said, it is what is, and what moves in the void, which he called what is not, and which he declares is no less than what is. The void, which is what is not, is no less than what is. His associate Democritus of Abdera likewise posited the full and the void as principles, of which he calls the former what is and the latter what is not. So we have this view that atomism can be stated simply and straightforwardly as the view that reality is atoms, which is equated with what is or being, and void, which is equated with non-being or what is not. And in particular, the relationship is that atoms are moving in this void. Motion is the common denominator or the link between these two aspects of reality, between atoms, which is or are what is, and void, which is what is not. But both are equally necessary to reality. So non-being is as necessary to reality as being. That's the atomistic position. The Eleatics, of course, Parmenides, Zeno, etc., denied the existence of a void. And against this, the atomists marshaled a number of observable phenomena that require positing a void for their explanation. So we see in number 17 here, skipping down to the underlined part after the, let's see, this is the fourth of the ellipsis there, the dots that signals something is missing. Beginning to quote here at that point, They say that 1, there would be no change in place, that is, motion and growth, since it does not seem there could be motion unless there were void, since what is full cannot admit anything else. Some things are seen to contract and be compressed. For example, they say the jars hold the wine along with the wineskins, since the compressed body contracts into the empty places that are in it. Further, 3, all believe that growth takes place through void, since the nourishment of a body or two bodies cannot coincide. And 4, they also use evidence what happens with ash. It takes no less water to fill a jar that contains ashes than it does to fill the same jar when it is empty. So, motion occurs in these ways, and motion is impossible without positing that there's some kind of a void. Without void, everything would be unable to move because bodies wouldn't have space to move into. Without empty space, thickening and thinning is impossible. Growth can only be explained if nutrition enters into the empty spaces between bodies. What happens with ashes, also suggests that there's empty space between bodies. 4, a jar filled with ash can hold almost as much water as when it's empty. So if motion exists, then empty space must also exist. Empty space is called the void, as we've noted. The void is what is not. The void is the place where there is nothing at all. The top of 17 there. By void, people mean an interval in which there is no perceptible body. Since they believe that everything that is a body, they say that void is that in which there is nothing at all. So void is where there is nothing at all, no body at all. And this is what allows motion to occur. Being is composed of indivisible bodies that fill up some portion of space. So these bodies, which are called atoms or uncuttables, literally what the Greek word means, uncuttables. So indivisibility is seen as being the primary quality or property of atoms, apparently. So atoms or uncuttables are the constituent elements or building blocks of reality. If being was infinitely divisible, it would dissolve into nothingness at the limit, and there would be no being. Aristotle cites an argument for atomism in number 14. I'll quote a large portion of this one. For there is a difficulty of this, beginning of the second line here, in number 14. For there is a difficulty in supposing that there is a body of magnitude that is everywhere divisible, and that this, the complete division, is possible. For what will there be that escapes the division? Now, since a body is everywhere divisible, this is the hypothesis that we're going to refute. Suppose a body is everywhere divisible, let it be divided. What then will be left? A magnitude? But that cannot be, for there will be something that has not been divided, whereas we suppose that it was everywhere divisible. If there's a magnitude, we'll suppose that there's something that hasn't yet been divided, but that contradicts the supposition or the hypothesis that we're dealing with something that's everywhere divisible. But if there is no body or magnitude left, and yet the division will take place, either the original body will consist of points and its components will be without magnitude, or it will be nothing at all, so that even if it were to come to be out of nothing and be composed of nothing, the whole thing would then be nothing but an appearance. Likewise, if it is composed of points, it will not be a quantity. For when they were in contact, there was a single magnitude and they coincided. They made the whole thing no larger. For when it is divided into two or more, the whole is no smaller or larger than before. So even if all the points put together, they will not make any magnitude. These problems result from supposing that any body, whatever of any size, is everywhere divisible. So the point, there's actually a couple different arguments here, but the point is that if being is infinitely divisible, it's going to dissolve into nothingness at the limit of divisibility, and then there's going to be no being, obviously, if it dissolves into nothingness. So a simplified version of the core idea here can be stated this way. I'll just make this into a simple three-premise argument. So premise one, suppose all body is divisible. Premise one, suppose all body is divisible. Premise two, in that case, when the body is fully divided, there is no magnitude left. Premise two, in that case, when the body is fully divided, there is no magnitude left. Premise three, but a body must have magnitude. Magnitude of some, however small, but some magnitude is essential to a body. So premise three, a body must have magnitude. And therefore, proposition four, the conclusion, there must be some indivisible bodies. The atoms are those bodies. So indivisible bodies are thus necessary in order for there to be any filled space. The atomist view was that, as stated in number 2, that all things are unlimited. All things are unlimited. So how do they reconcile this view that all things are unlimited, which of course seems to recover something of Anaximander's metaphysics, with the idea that reality is just atoms and void? Well, the way they did this was to say that there are an infinite number of atoms, so that there are an infinite number of these, and that the void is infinite in extent. There's an infinite void or empty space. If you look at number 5, quoting here from Simplicius, who was quoting Aristotle, who was talking about Democritus. Democritus believes that the nature of the eternal things is small substances infinite in number. Infinite in number. As a place for these, he hypothesizes something else, infinite in size, and he calls this place by the names void, nothing, and the unlimited, and he calls each of the substances king, den, that is thing, and the compact, and what is. So, contra the Eleatics, the atomists were metaphysical pluralists. There are many, indeed infinitely many beings, and not just one. So that's the contrast I'm referring to here. The Eleatics, like Parmenides, are monists, meaning that they believe in just one reality. One reality is the one, and there's only one thing, so to speak, in reality. Whereas the atomists are metaphysical pluralists. And to the extreme extent, they're positing an infinite number of things, an infinite number of atoms. This leads us to the first discussion question. Is the atomist metaphysical theory that posits an infinite empty void of non-being occupied by an infinite number of beings a plausible one? Is it really plausible to posit the existence of an empty void in order to account for motion? Or let's say, is it really necessary to posit the existence of an empty void in order to account for motion? Why or why not? Do the atomists have an adequate response to Parmenides' axiom that non-being is not? So once again, first discussion question, is the atomist metaphysical theory that posits an infinite empty void of non-being occupied by an infinite number of beings a plausible one? Is it really necessary to posit the existence of an empty void in order to account for motion? Why or why not? Do the atomists have an adequate response to Parmenides' axiom that non-being is not? Despite their disagreement over motion, non-being, and pluralism, Leucippus and Democritus apparently agreed with the Eleatics to this extent. Beings must be infinite and indivisible, and also the same at every point, or homogeneous, not different in kind, as is attributed to Democritus in number 28. That these atoms are not different in kind, they are homogeneous. So, contrary to Empedocles' view, the elements of reality are not irreducibly qualitatively different at the fundamental level. Remember, Empedocles had the view that at the fundamental level there are these 6 elements of reality, and even though they enter into different combinations, none of them are reducible to any of the others. So we have the 4 material elements and love and strife for Empedocles. But for Democritus, for example, the elements of reality are not qualitatively different at the fundamental level. And in fact, they have no qualities at all. This is clear in a number of places. For example, in number 9 is particularly clear, where it says, Democritus held this view because there is by nature no perceptible substrate, since the atoms which combine to form all things have a nature deprived of every perceptible quality. So the atoms do not have qualities. Instead, the atomists tried to account for the qualitative differences of things that we observe in our everyday lives in terms of the quantitative, that is to say, the measurable distinctions of their constituent atoms. So let's look beginning at number 30. Leucippus and Democritus, calling the smallest primary bodies atoms, say that by virtue of differences in their shape and position and order, some bodies come to be hot and fiery, those composed of rather sharp and minute primary bodies situated in a similar position, while others come to be cold and watery, those composed of the opposite kind of bodies. And some come to be bright and shining, while others come to be dim and dark. So we account for the difference of qualities of things being bright or dark or wet or dry or hot or cold in terms of underlying minute primary bodies, the atoms, that are in a different position and a different shape, whether they're sharp or whether they're dull and so forth. 31. He makes sweet that which is round and good size. So atoms that are round and good size are sweet. Astringent that which is large, rough, polygonal, and not rounded. Sharp tasting, as the name indicates, sharp and angular in body. Bent, fine, and not rounded. Pungent, round, small, angular, and bent. Salty, angular, good sized, crooked, and equal sized. Bitter, round, smooth, crooked, and small sized. Oily, fine, round, and small. So we have a complete theory here of the different qualitative tastes in terms of the different shapes and sizes of the underlying atoms. So we reduce what's qualitative into what's quantitative and what could be measured. And then things like density or space also figure in here. Number 32, iron is harder and lead is heavier. Since iron has atoms arranged unevenly and has large quantities of void in many places, while lead has less void. So you account for the difference between iron and lead in terms of how much void is in between the constituent particles. And you can also account for heaviness and softness and so on in this way. So Democritus will later go on to say that qualitative differences are the result of convention, not nature. In reality, there are only quantitative differences and no qualitative. And number 3, Leucippus and his associate Democritus declare the full and the empty void to be the elements, calling the former what is and the other what is not. Of these, the one, what is full and solid, and the other, what is not, is empty and rare. This is why they say that what is no more than what is not, because the void is no less than body is. These are the material causes of existing things. They declare that the differences among these are the causes of the rest. Moreover, they say that the differences are three: shape, arrangement, and position. I'll say that again, but that's the key takeaway here. The differences are three: shape, arrangement, and position. For they say that what is differs only in rhythm, touching, and turning. And of these, rhythm is shape, touching is arrangement, and turning is position. For A differs from N in shape, AN from NA in arrangement, and Z from N in position. Z and N being the same in shape, but one is, as it were, turned on its side and the other is turned upright. Seems to be the point there. So those are the three: shape, arrangement, and position are the three ways in which atoms are different, according to Aristotle's account of the atoms. Atoms differentiate by shape, and shape, as it turns out in some of these other fragments, including ones I've read, seems to include the idea of differences in size as well. We might distinguish between shape and size, or size might be part of the understanding of arrangement, depending on how you look at it. But we could say, based upon the overall impression that one gets from the surviving fragments taken together, that shape, size, arrangement, and position are all elements of the atoms. So there are definitely different shaped atoms, different sized atoms, and atoms can be positioned in different ways relative to one another. The later atomist Epicurus, according to number 10 here, apparently added that atoms have weight as well. Democritus, it seems, may have sought to account for weight in terms of the atoms striking against one another. Weight in terms can be reduced to impact, in other words, in Democritus's account, according to at least one fragment, number 21. But the accounts seem to disagree about this. So if we compare 21 to 22, we see an apparent disagreement. But the basic point is that qualitative properties were to be reduced to quantitative properties. And whether we limit these to just shape, size, arrangement, or position, or add weight as a separate distinct one, is perhaps less important. So Democritus is going to reduce Empedocles' 4 elements, or 6 if you include love and strife, but just taking the 4 material elements, he's going to reduce these to differences in the size and shape of the atoms that constitute them. Specifically, Democritus considered fire to be the only uniform shape among the 4 elements. He regarded fire as composed uniformly of the very smallest type of atom, the smallest in size, and to be composed of spherical atoms. So fire is composed of the tiniest and the most spherical atoms, whereas the other 3, air, water, and earth, are composed of mixtures of different types of atoms of different shapes, according to Democritus. Qualities, then, are going to come from the way in which these atoms affect the sense organs. Different sense organs will be affected differently, resulting in subjective differences due to what's later in a fragment called convention. We'll come back to that in a bit. First, I want to talk about what a thing is on this account. So, ordinary everyday things, stones, living things like trees, also animals, manufactured goods, whatever it might be, the ordinary everyday objects of our everyday experience are going to be understood as a complex of atoms. A thing comes into being when a complex of atoms is formed, and it goes out of being when the complex breaks apart. And this applies to these everyday objects that I was just referring to, But it also would apply to things like the earth or the heavenly bodies. The same principle applies apparently to all. So let's look at number 4. After establishing the shapes, Democritus and Leucippus based their account of alteration and coming to be on them. Coming to be and perishing by means of separation and combination, alteration by means of arrangement and position. Since they held that the truth is in the appearance, and the appearances are opposite and infinite, they made the shapes infinite, so that by reason of changes of the composite, the same thing seems opposite to different people, and it shifts position when a small additional amount is mixed in, and it appears completely different when a single thing shifts position. For tragedy and comedy come to be out of the same letters. It's sort of a literary flourish that Aristotle ends with there. But the idea here is that the basic constituents always remain the same. The individual atoms always remain the same, unchanging, but they come together in potentially an infinite number of ways, because there are an infinite number of atoms, an infinite number of shapes and sizes, and these come together in various ways. And of course, not only are the things able to come together and break apart as their atoms are rearranged and brought together in different ways, but also the way in which we perceive them is going to differ based upon the way in which these atoms interact with the atoms that make up our bodies. We'll come back to that point as well a little later. So alteration in a thing is due to the rearrangement of the constituent atoms. Growth in a thing involves the entry of new atoms into the complex. So you can explain growth by just saying that, well, the reason that tree grows is new atoms are coming in through nutrition, for example. And so you have a purely mechanistic theory that enables you to explain what we see in terms of generation, change, and growth of everyday ordinary objects. And a view that in principle could also apply to the Earth as a whole, to the planets and the stars and the sun and the moon and so forth. Clearly, atomism is the least mythical of the ancient Greek systems. Democritus is said to have rejected the notion of purpose as an explanatory principle of nature, the notion of teleology, as is suggested in number 24. Nature is thoroughly mechanical, with no mysteriously anthropomorphic principles such as love, strife, nous, or logos. Motion and impact are all that it needs to explain change. You can see how far from a mythical explanation of thunder, lightning, and rainstorms, and how close he is to a modern scientific understanding of those things in the following passage, number 37. It's on page 57. Democritus stated that thunder results from an uneven compound forcing the surrounding cloud to move downward. Lightning is the collision of clouds, as a result of which the atoms that generate fire are filtered through interstices containing much void, a process that involves friction and collect in the same place. A thunderbolt occurs when there is a violent motion of fire-producing atoms that are very pure, fine, even, and close-fitted. The word Democritus himself uses. A waterspout occurs when compounds of fire containing much void are held back in regions with a lot of void and are wrapped in special membranes and form bodies because of this rich mixture and make a rush toward the depth. As a result of this privileging of the mechanical explanation of things over the mythical, atomism turned out to be the most consequential for the development of modern science of all of the pre-Socratic theories, particularly when it was revived in its modern form in figures like Galileo, Boyle, and Locke. According to Diogenes Laertius, the world is formed for Leucippus by atoms falling through an infinite void. So, Leucippus's position is this. This is number 2. Leucippus's position is this. All things are unlimited and they turn around one another. The universe is both the empty, void, and the full. The worlds come to be when the atoms fall into the void, and are entangled with one another. The nature of the stars comes to be from their motion and from their increase in entanglements. The sun is carried around in a larger circle around the moon, whirled around the center. The earth rides steady. Its shape is drum-like. He was the first to make the atom's first principles. So the explanation of the formation of, you might say, the original bodies is you have to imagine an infinite number of atoms that are falling just vertically. So this is understood as being sort of the simplest type of motion, just vertical descent, just falling. And originally they're falling, but because of their different sizes and so forth, they come to be, and there are an infinite number of them, they somehow come to be entangled with each other. And this might be a bit of a problem. Why don't they just all fall separate from each other if there's void between all of them? How do they come to be entangled? But at any rate, the atomistic theory is that they come to be entangled, they come to ricochet off each other, and eventually they start to, because they're entangled, they start to clump together and form various types of bodies of different density depending on how much void is in them and so forth. And this has been going on from all eternity for an infinitely long time. And of course, this falling is never going to cease because there is no, as it were, bottom to the void for them to get down to. The void is infinite, so the falling is going to continue. But it's no longer just straight falling. It's now a kind of helter-skelter, sort of like a cosmic mosh pit with all the atoms sort of bumping into each other and forming clusters as they become entangled with each other and so forth. That's the view. Of course, you might ask, well, why doesn't the Earth appear to be falling? And you might guess at what their answer would be, the probable answer, because everything at the Earth is falling at the same rate. The same reason we don't feel like we're moving, even though the Earth on which you are moving is. Same reason that your friend in your car doesn't appear to be moving, and so forth, because we're all falling at the same rate. So the Earth is formed then of these atoms of different shapes and sizes, which collide, ricochet, whirl about each other, and become entangled, which sounds like a rather chaotic process. And you might think that this is a process that's just governed by chance and randomness. But the atomists apparently viewed it as occurring with a certain necessity. So the very first of our fragments states, "No thing happens at random, but all things are the result of a reason and by necessity." And also in number 25, concerning necessity, Democritus says it is the knocking against each other and the motion and the blow of matter. So how these things knock into each other, it's all governed by necessity. It's not random. You might have the image of the lotto ball machine or something which seems random, but of course, modern science would say it's not random at all, which lottery ball comes out. If we knew, the initial conditions and we could calculate every, behavior of every ball according to the forces of nature, we'd be able to calculate which one was going to come out. And it's only our lack of data that prevents us from seeing that and thinking that it's random. So this view of the apparent chaos of reality is actually a view that reality is governed by a mechanical necessity. This process then leads to composite masses of different densities and weights, as we see, as already mentioned, and we see it number 27, for example. This is number 27 on page 56. These atoms, which are separate from one another in the infinite void and differ in shape and size and position and arrangement, move in the void, and when they overtake one another, they collide, and some rebound in whatever direction that they may happen to, but others become entangled by virtue of the way of their shape, size, positions, and arrangements. And these correspond, and they stay together, and this is how compounds are produced. So there's a suggestion here of an explanation for why they don't all stay in their lane from all infinity is that some of them apparently are heavier, is the view, or for some reason are falling faster, perhaps because of their greater size, and those overtake the ones below them, so to speak. And that's how they run into them. And then because they have different shapes, they'll ricochet and bump into other ones next door, and then you get a chain reaction. And then these are the way the composite masses are formed when they become entangled with one another. Okay. So back to this quality, back to rather this issue of how the perception of quality arises. Since atoms have no qualities, how does the perception of quality arise? Well, according to Democritus, the soul, or the perceptive power in our body, is itself composed of tiny atomic particles, which are moved in the same way as all the other parts of the body are. So this is described in number 38 on page 58. Some say that the soul moves the body in which it is found in the same way as it itself is moved. Democritus, for example, who has a view like Philolaus, the comic poet, who says Daedalus made the wooden statue of Aphrodite move by pouring quicksilver into it. Democritus speaks similarly, since he says that the indivisible spheres are in motion because their nature is never to stay still, and to draw the entire body along with them and to move it. But we will ask if these same things also produce rest. How they do so is difficult or impossible to state. In general, the soul does not appear to move the body in this way. This is Aristotle's commentary now on Democritus in De Anima, which we'll discuss later on. The soul does not appear to move the body in this way, but through choice of some kind and through thought. So Democritus' view is that the soul, or the animating principle in the body, is really just a finer form of material. And the analogy here is with Daedalus, who made the wooden statue of Aphrodite move by pouring quicksilver into it. So too does our soul make the body move. It's just a finer, more rarefied composite of atoms. So you have a thoroughly materialistic view. And likewise, sense perception is going to be due to, according to Democritus, it's going to be due to streams of atoms flowing in the air, which he calls an effluence from the body to our sense organs. So we sense a body, what's going on. There's a stream of atoms that's flowing in the air from the body to or through the ether or what have you, from our body to our sense organs. And this is in number 39. The visual impression is not formed directly in the pupil, but the air between the eye and the object is contracted and stamped by the seen object and by the seeing thing. For there is a continual effluence from everything. Then this air, which is solid and has different color, forms an impression in the eyes, which are moist. There's a continual effluence from everything. So there are atoms flowing out from every body. You might imagine that this occurs because bodies are always porous. There's always some void in any body. And so it's possible for atoms to flow through them. And this explains sense perception. These atoms that are flowing through one body come to impact on another body. And the result is that there's some perception of that first body. But the accuracy of this perception is going to be very much in doubt. Any impression that we have of a body at some distance from us that comes from this kind of process of an effluence from that body coming to flow into us isn't likely to raise a lot of, shall we say, epistemic confidence in us, that we're actually perceiving the body in any kind of accurate way. And in fact, the atomist theory of perception, according to the atomists themselves, or at least Democritus, implies that most of our judgments about the nature of reality, because they're based on the senses, are, strictly speaking, false and merely based on convention. Today we might say socially constructed. So 41, he says, there are two kinds of judgment, one legitimate and the other bastard. All the following belongs to the bastard: sight, hearing, smell, taste, and touch. The other is legitimate and is separate from this. When the bastard one is unable to see or hear or smell or taste or grasp by touch any further in the direction of smallness, but we need to go still further towards what is fine. Then the legitimate one enables us to carry on. So the idea here is that we can make these judgments about the correct philosophical theory of reality. Those aren't bastard judgments, but the judgments we make about just on the basis of our senses, these are bastard judgments. They're not legitimate judgments, in other words. And also in 42, by convention sweet, by convention bitter, by convention hot, by convention cold, by convention color, but in reality, atoms and void. That sums up the distinction that he made in 41 very succinctly. All of these judgments that we make on the basis of the senses, like, ooh, this is cold, this is wet. These judgments are merely judgments by convention, not by nature or by reality. Thus, just as with modern naturalism and materialism, atomism ends up in a somewhat skeptical and pessimistic posture regarding our ability to know anything. So you see this in the series of brief fragments after 42. 43, a person must know by this rule that he is separated by reality. 44, in fact, it will be clear that to know in reality what each thing is like a matter of perplexity, or that people are at a loss to know in reality what each thing is like. And 45, in reality, we know nothing about anything, for each person's opinion is a shaping of the soul atoms by the atoms entering from without. And 47, skipping that one, 46, in reality, we know nothing, for truth is in the depths. So this materialistic, mechanistic, demythologized conception of reality that seems, I think, to modern people so scientific, also turns out to be the one that leads to the most skepticism and the most pessimistic attitude towards certain knowledge, and circumscribes or restricts the knowledge that human beings can obtain the most. But this is no cause for angst or concern. The atomists advocated a balanced life, moderate in its enjoyments and untroubled by superstition. So the last two fragments there, 50 and 51. Cheerfulness arises in people through moderation of enjoyment and due proportion in life. Deficiencies and excesses tend to change suddenly and give rise to large movements in the soul. Souls that undergo motions involving large intervals are neither steady nor cheerful. In 51, the goal of life is cheerfulness, which is not the same as pleasure, but the state in which the soul continues calmly and stably, disturbed by no fear or superstition or any other emotion. He also calls it well-being and many other names. So this is sort of the ethical upshot of adopting this atomistic, despiritualized, disenchanted view of nature. There's a kind of cheerfulness that comes from moderation in life and abandonment of superstition. This leads to the second discussion question. Do you think that atomism can explain all aspects of reality? Are there apparent realities that it has difficulty accounting for? For example, can atomism account for animal sentience generally, and human cognition specifically? Can it account for the unity and coordination of the different organs of a living organism? So this is the second discussion question. Do you think that atomism can explain all aspects of reality? Are there apparent realities that it has difficulty accounting for? For example, can atomism account for animal sentience generally and human cognition specifically? Can it account for the unity and coordination of the different organs of a living organism? That's the second discussion question. Okay, now briefly, I want to talk about two later pre-Socratic philosophers who belong to earlier schools that we already talked about, namely the Eleatic school of Parmenides and Zeno and the Pythagorean school. And we look at these two philosophers as individuals who represent, above all, the continuing relevance to of these older philosophical schools to the philosophical climate and milieu in which Socrates and Plato began to be active. And so, just because we left Parmenides and Pythagoras in the dust, several philosophers ago now, doesn't mean that they didn't continue to be relevant and their views didn't continue to attract followers. And so these later followers that are going to be expressing more refined versions of these views that are meant to take account of and to respond to the criticisms and the new alternatives that you see arise after the earlier schools. So Melissus of Samos, for example, was a Parmenidean who advanced arguments defending the Eleatic position against the attacks of various post-Parmenidean philosophers, including Empedocles and Anaxagoras and the Atomists. And in these arguments, I think we can summarize their upshot in terms of the central importance of the axiom, what is cannot be. What is cannot be. We know that atomists expressly assert the existence of what cannot be. That's part of the theory. The whole theory of atomism collapses without the void. But the void is expressly characterized as what is not. We saw that in several fragments that we read. So the Parmenidean position, of course, is that what is cannot be. That's axiomatic. And we see in Melissus the continual assertion of this principle. So this is fragment 7, page 60. This long 7 is a long fragment, so we're looking at about the fourth paragraph from the end of this one. Nor is any of it empty or void, for what is empty is nothing, and of course what is nothing cannot be. Nor does it move, for it cannot give way anywhere, but it is full. For if it were empty, it would give way into the empty part. But since it is not empty, it has nowhere to give way. Melissus also uses the principle that what is not cannot come to be against the various reductionistic positions from the Milesians to Empedocles and Anaxagoras. So you see in the next fragment there, this is beginning in the third paragraph, this is on page 61. We think that what is hot becomes cold and what is cold hot, that what is hard becomes soft and what is soft hard, that the living dies and that it comes to be from the non-living, and that all these things come to be different and that what was and what is now are not at all alike, but that iron, although hard, is worn away by contact with the finger, and also gold and stone and anything else that we think is enduring, and that the earth and stone come to be from water. Hence, these things do not agree with one another. For although we say that there are many eternal things that have definite forms and endurance, we think that all of them become different and change from what we see at any moment. Hence, it is clear that we do not see correctly and are incorrect in thinking that those many things are. For they would not change if they were real, but each one would be just as we thought, for nothing can prevail over what is real. But if it changes, what is was destroyed, and what is not has come to be. Thus, if there are many things, they must be such as the one is. So we can see from these arguments that the Parmenidean is going to continue to assert the illogicality of positions such as the atomistic one that we just looked at. There's a logical contradiction at the heart of such systems, and that is the assertion that what is not is. That what is not is. The difficulty of overcoming such arguments shows the survival and the enduring viability of the Eleatic position well into the time of Socrates. And then finally we have later Pythagoreanism, represented by Philolis of Croton. Philolis was a later member of the Pythagoreans who grappled with the post-Pythagorean schools of philosophy from a Pythagorean perspective. How does the Pythagoreans' allegiance to mathematical science stand up to the monism of the Eleatics of Parmenides and Zeno? If Parmenides is correct, being is one, indivisible, motionless, and changeless. Mathematics, however, presupposes multiplicity, divisibility, alteration of sequences. Further, mathematics presupposes the possibility of what Philolis calls limiters, as well as the unlimited or the infinite. Mathematical concepts are exact concepts, and these presuppose definite limits. If something is numerically 1, it's limited. It cannot be 2, 3, or 4, etc. If something is a line, it cannot have 3 dimensions, and so forth. Thus, it would seem that mathematics is inconsistent with the Eleatic doctrine that being is infinite and unlimited. For this reason, Philolis rejects that doctrine. Instead, limiters and the unlimited are equally necessary. Limiters and the unlimited are equally necessary. Again, this point can be gleaned from mathematics. Mathematical entities like numbers are not only limited, they are themselves carved out of and hence dependent upon the limitation of a limitless series. The number 4 gets its specific identity not just intrinsically, but by being a precise point in an infinite sequence that includes the numbers 1, 2, 3, as well as 156, 120, 1,987, and so forth. So the number 4 is part of the sequence that leads all the way up to 121,989 or whatever. And it gets its identity as 4 by virtue of its relation to that much larger number, as well as all the numbers in between and the numbers that preceded it. Both the limiters and the unlimited are thus necessary to reality from a Pythagorean perspective. So we see, number 1, nature in the cosmos was joined from both unlimiteds and limiters, and the entire cosmos and all the things in it. And number 2, it is necessary that the things that are be all either limiters or unlimited, or both limiters and unlimited, but not in all cases only unlimited. Now, since it is evident they are neither from things that are all limiters, nor from things that are all unlimited, it is therefore clear that both the cosmos and the things in it were joined together from both limiters and unlimited. So that's Philolis's later Pythagorean position, is that reality is going to require some kind of unity of both limiters and the unlimited. Now, there's an obvious problem with the view that both the limiters and unlimited are necessary to reality. Since these are contrary to each other and actually seem to negate one another, the problem is to explain how they can possibly coexist in a unity. In other words, what's doing the job here of unifying these two? And the proposal is going to be that there's a kind of harmony, that a harmony is doing the job. To solve the problem of the unity of the limiters and the unlimited, Philolis proposed that reality was a oneness that was a harmonia. And number 6, concerning nature and harmonia, this is how it is. The being of things which is eternal, that is in their very nature, admits knowledge that is divine and not human, except that it was impossible for any of the things that are and are known by us to have come to be if there did not exist the being of the things from which the cosmos is constituted, both the limiters and the unlimited. But since the principles are not similar or of the same kind, it would be completely impossible for them to be brought into order or for them to be kept in an ordinary arrangement or cosmos if Harmonia had not come upon them in whatever way it did. So Harmonia is the principle. Harmonia, of course, this is a concept that comes from music. As with most Pythagorean doctrines, there's something a bit mysterious and esoteric about what the actual content of the doctrine is supposed to be, and it's subject to various interpretations. However, at a general level, we see how a harmony in music is capable of bringing together and, in a way, canceling out the contrariness of two distinct tones. This was apparently the acoustic phenomenon that Philolis used in order to explain how the limited and the limitless can be reconciled with one another. Philolis thus used the notion of harmony to understand the structure of the cosmos. But how can the notion of harmony reconcile the limiters and the unlimited? The unlimited has no boundary. The limiters require a boundary. So where does the harmony come in? The key Pythagorean notion here was the notion of the middle, which is the basis of the harmony. The limiters and the unlimited meet in the middle. The midpoint represents the common limit of an unlimited series of spheres of progressively larger sizes that extend around it. So you have the midpoint of this sphere, and then that's also the midpoint of a larger sphere around it, and a still larger sphere, and so on. These all harmonize in the sense that they share a common ratio, just like a musical chord. The Pythagoreans famously conceived of the Earth as such a sphere, and so inspired later astronomers like Copernicus. The soul was likewise conceived as a kind of harmony within the body. The characteristic Pythagorean attitude towards reality was to see echoes of everything in everything. Everything is analogous to everything else, sharing similar ratios, and all belonging to a universal harmonious cosmos. So the physical or natural or cultural or social were not radically distinct from them, but governed by a shared principle of number. And you see this in the last fragment from Aristotle's Metaphysics, number 14. In numbers, they, the Pythagoreans, thought they observed many resemblances to the things that are and that come to be. Such and such an attribute of numbers being justice, another being soul and intellect, another being decisive moment, and similarly for virtually all other things, since all other things seem to be made in the likeness of numbers in their entire nature. Okay, so this provides a new twist on the Pythagorean idea that all reality is number. All reality is the harmonious ratio of these different relationships between the limiters and the unlimited. This completes our survey of the main philosophers of nature before Plato. With the final group of pre-Socratics, a shift occurs to ethical and psychological concerns, and these are the sophists, which we will take up next.